Hey, good day, guys. I wanted to make a lesson for you uh, with the PowerPoint I was going to use in class. So I am recording that right here. This is the second time I've tried, so hopefully this will work. Anyway, if it doesn't, I'll do it another way. So this is my second attempt. Anyway, this happened. So for the lesson today, I really wanted to take a deep dive on what it means to demonstrate thinking. Because a couple of things are happening on the homework where people should be able to get full credit, but they're not. They're not demonstrating that they really understand what goes on. And it leaves me with that feeling like people are just copying answers, and I hate that. I want you to go beyond copying to really being able to demonstrate that you know what you're doing mathematically and to be honest with yourself when you don't know so that then we have questions and I can bring those to class or office hour and help you with whatever issues exist. Okay? So let's get going. We'll go to the next slide. Okay, first problem. On this problem, I have this example from a student who does very well, but this particular problem set they didn't do well on. They have not demonstrated how they know these answers are correct. Now, I have every sense that they probably know why those answers are correct, but they have not demonstrated it. And so I want to show you how you can do that, all right, for this problem. So, um, on this problem, you are asked which of these points are on the graph of the inverse function of x, the arc sine of x. So we want to do a graph y equals the inverse function of x, or the inverse sine of x. And we want to figure out which of these points are on that graph. Now, these answers are correct, but they could have just copied this. All right. Now, handwriting that will help them learn something, but they're not going to really know why each of these check marks exist here. And you need to justify why each of those 8 check marks are in the box that they are. Okay. And I don't mind if you have to look and it goes, okay, this one's off. Okay, how can I decide if it's off? So the easiest way is to start off with the domain. What is the domain of the inverse function of x? Well, the domain is all the x's that are in the interval, closed interval, from -1 to 1. And the range is all the y's that are in the closed interval from -pi/2 to pi/2. And so if I write that down, I am now saying I am going to use the domain and range to help me determine which of these points work and which of these points do not work. Okay? And so the first thing I'm going to notice is that the domain is from -1 to 1. That means any x value that is bigger than 1 or less than -1 is not going to be on the graph because they're not actually in the domain. All right. And so this becomes pretty easy to pick out 2 of these right away. So I'm going to pick out 2 of these, pi1 and pi/2 1. Those are not going to be on the graph. Okay. Why are they not on the graph? Because pi and pi/2 are both greater than 1. They're outside the domain, therefore not on the graph. So outside domain, therefore not on the graph. Now, pi over 2 is about 3.14 over 2, or about 3 halves. So, or 1.57 if you wish. And so that's obviously bigger than 1. So it's not outside the domain. So now we have solved those two. We know this one and why those are correct. Okay? So let's do, we can do this with the range as well. Okay? With the range, everything has to be between negative pi over 2 and pi over 2. So if anything is outside that range and the 1 pi is one of those, though that one is outside the range. Okay? And so we use the domain to find two of these answers and the range to find one of them. And that happened right off the bat. Okay? That really helps us. So now, the other thing we have to look at, sorry, I had a bit of a yawn there. The other thing we have to look at is we have to look at the table function. Okay? Now, if you'll remember, if I have sine here, and then I have the angle 0, pi over 6, pi over 4, pi over 3, and pi over 2, then the values are 0, 1/2, square root of 2 over 2, square root of 3 over 2, and then 1. Okay? Now, why does this help? Well, the special angles tell me that if I have 0, and then remember 0 corresponds to pi, 2 pi, it's the reference angle for all of those, all right? Pi, 2 pi, 3 pi, negative 2 pi. So I'm going to look, do I have any reference angles of pi that I haven't already thrown out that I should check? So I'm looking at domain values, and the domain values I'm looking at are this pi over 2, this 1, this pi over 2, this 1, oh, we threw that one out, excuse me, this pi over 3, and this 1/2. Now, remember, this is for sine x, so I need to go backwards. So going backwards would mean 0, comma, 0 pi, 2 pi. But if you look at this, only 0, 0 fits the domain in the range. That is not one of my choices that I have there. So I don't need to worry about that, all right? And so I'm going to highlight these ones I've already figured out a little better. Okay, so I don't look at them again. Okay, all right, so those are done. So then I go, gosh, do any of these start with a 1/2? And I do have one down here, it's 1/2, and then it says pi over 3. So 1/2 pi over 3, all right? But according to this, it should be 1/2 pi over 6. That's why this one is not on the graph. It has the wrong range value, okay? And then I go, did any of them start off with square root of 2 over 2? No. Did any of them start off with square root of 3 over 2? The answer is yes. square root of 3 over 2, pi over 3. That is a correct ordered pair, so this one is correct. Okay, that one's correct. Now, and then I go to 1, and 1 should be matched up with pi over 2, right? 1 should be matched up with pi over 2. So I go look at this, and I have 1 and pi over 2. So this one is also correct. Okay? So these are the two where I had correct solutions. So now I look at the other ones, and I have pi over 3 1/2, and I have pi over 3 square root of 2 3 over 2. Now you might be faked on these, but these are not on the graph because, so you would say these are not on the graph. Uh, First of all, these are the ordered pairs have the angle first and the ratio second instead of the ratio first and the angle second. Okay, so that's the main reason that those are off. Okay, and now we've figured that one out and that one out. And you have to write an explanation for each and every one of those. Okay, and that's how you do this problem. All right, you're demonstrating thinking, okay, not just getting correct answers. All right. Now, this assignment by a student, I only had a couple of students who had done this assignment. So um, this student did a little better. So the first things first, they said, okay, the first number has to be a ratio, and the second number has to be an angle. And that's what'll help them with some of these. This, they have an angle first, angle first, angle first. So they could throw out all three of those just based on first things first. The ordered pairs are not in the correct order. Okay? Then they said eliminate any answers that don't fit with the domain and range. And so that was 1 pi, pi over 2, 1, pi 1. Those are secondary reasons on the pi over 2, 1 and the pi 1. This first thing, making sure things are in the right order, would have been enough. And so you can eliminate choices that are not in the domain and range, okay? And the pi over 2, 1 is one of those. And so you could have eliminated that, all right? So that leaves you the 1/2 pi over 3 and the 1 pi. And the reason they're eliminated is they go to the wrong value, right? It should be 1 pi over 2 and 1/2 pi over 6, right? And then you do the correct ones, and you can use the table for that, okay? Now, notice this student had a comment on the bottom, and they said, I didn't quite get all these. I wasn't sure how to make sure I could say where it went. So this student gets 1, and even though the previous student had all the correct answers, they have no reasoning at all like this student. So I would give them 1/2. Okay? Telling me why answers are true is the most important thing. Just do not copy things, the answers that you see. All right? Okay, here's another issue that pops up. I've started to see this as well. And so what students are doing is they're trying to save time. A student always wants to save time. I don't care about you saving time. What I care about is that you show understanding. And so I'm going to ask the following question. Is it okay to ever put a multiple choice answer without the reasoning for why you picked it? You must have reasoning. So this right here has no reasoning. Also, you must actually put the actual answer. Just putting letter B doesn't allow me to check and see if you actually did pick the correct graph. Make sense? It's very important that you do that. Okay. So, don't just write letters down. Okay, that's a big deal. Okay, what's coming in the future? So in the future, we have a few things coming down the pike. The main thing is, um, why do we need inverses anyway? Why did we talk about inverses? And the main reason we use inverses is to solve equations. All right. And if you remember, if we solve an x squared equation, we take the square root of both sides. If we solve a logarithm equation, we take the exponential of the base of both sides. So we need inverses to be able to solve equations. And we're going to do that with trigonometry as well. So you have to know the domains. Domains going to be very important for solving trig equations, and um, I just have to be ready for all of that coming down the pike. That'll be about the middle of chapter 3. All right. The other big thing I want to talk about is graph without technology first. So almost 100% of our graphing problems can be done on a graphing calculator. However, if you do it on a graphing calculator, you will not know the trigonometry that you need to know. And what do I mean by that? When we go to graph and trigonometry, we want to do transformations, just like we did for x squared. We want to move left, right, up, down, stretch, compress, and so forth. The weird thing is, though, is because trig functions are periodic, what appears to us as stretches like this, in periodic functions can look like stretches like this. In other words, like an accordion, or those little hand accordions squeezing in together, where the curves get closer and closer together or further and further apart, depending how you pull it. And there's a big difference on trig functions, and you have to be able to do these things by hand to have it really cement in your brain what happens. And there's algebra to do. You have to understand why the graph is correct and be able to explain that in your homework, not just draw the correct picture or pick the right multiple choice. I want you to be able to tell me why that graph is correct. Why is C correct? And so you need to get in the habit of not graphing on Desmos or a graphing calculator until you have made your choice. Once you make the choice through logic, through trigonometry, then check and see if your intuition's right. If it's not, then you have to ask yourself, well, what mistake am I making? Where is my understanding incorrect? That is very important. That's where we're heading. Okay? And we'll be doing more of that on Thursday, and you'll be doing quite a bit of it the next probably 3 days in class. So it's really important you watch the videos, or find Khan Academy videos or Chemistry Tutor, whoever's videos you like, and really kind of get a handle on how transformations work for trig functions. Okay? All righty. That's all I have for you today. Thank you so much. All right, and good luck. I'll email this, link it to this for everybody. All righty, bye.